Namaskar, welcome to Upgraded Than Yesterday, the place where we level up our knowledge every single day. Today, let's understand the solid principles. The solid principles are 5 essential guidelines that enhance software design, making code more maintainable and scalable. In solid, S stands for single responsibility principle, O stands for open and close principle, L stands for Liskov Substitution Principle, I stands for interface segregation principle. D stands for Dependency Inversion Principle. Please remember this full form. To explain the solid principles, let's take an example of restaurant. Suppose we are asked to design a restaurant management system. If we think with the object-oriented concept, a restaurant can be divided into many parts, and among those, two major parts are restaurant staff and food menu. Please observe the diagram carefully. The actors like chef, cashier, waiter, manager, etc. are part of the restaurant staff, and the type of the food like veg food or non-veg food are part of the food menu. Now let's understand the first principle of solid, which is single responsibility principle. This principle says that a class should have only one responsibility or only one job to perform. That means in case of any modification, there should be only one reason to modify it. Let's understand the single responsibility principle with a simple class. Suppose restaurant service has three methods like take order, cook, and bill processing. But I have marked it as bad code. Can you tell me what is the problem with the written code? The restaurant service class will be modified in case the cooking process is changed, or the order taking process is changed, or the billing system is changed. That means the class has multiple reasons to get modified, which is violating the single responsibility principle. The solution is to segregate the code into multiple classes based on their responsibilities, so that each class can have a single and well-defined job to perform. Please observe the code written in the right side. Since cooking, taking order, and billings are different responsibilities, so this restaurant service class can be segregated into three different classes like cooking service, order service, and payment service. Cooking service and order service is shown here, but since there is no space left to write the payment service, so it is not shown here. But I hope you got the idea, right? This is how we can design any class by following single responsibility principle. Coming to the next principle, which is open-close principle. According to this principle, any software entities like classes, modules, methods, etc. should be open for extension but closed for modification. That means this principle stops us from doing unnecessary modification to any existing module, so that unwanted bugs can be avoided and retesting efforts can be reduced. Let's understand it with an example. Suppose we have created a class payment processor to handle the restaurant bill payment. Here, the class is supporting two payment methods, UPI and cash payments, and it has been handled with a simple if-else condition. So far so good, right? But I have marked it as bad code, as it is not designed as per solid principle. So, what are the problems in the written code? This method will be modified every time if a new payment method is added. For example, credit card. One more if condition will be added to support this new credit card payment method. Or in case of removal of an existing payment method, we need to delete that code block. Since this method is open for modification, so the written code is violating the open-close principle. This problem can be solved by segregating the code into multiple classes and interfaces based on the payment types. Here, let's create an interface called payment with a method pay. Now every payment type class will be inherited from this interface, and the pay method will be implemented inside every subclass. So, whenever there is a need of additional payment type to be supported, we don't have to modify any class or interface. Instead of it, we can simply create one more subclass of payment interface and implement the pay method. Also, if there is a need of removal of any existing payment type, just simply delete that corresponding subclass of payment interface. This way, the class becomes open for extension and closed for modification. Let's understand the third principle, that is Liskov Substitution Principle. As per this principle, any derived or child class must be substitutable for their base or parent class without breaking the behavior of the program. To understand it, let's try to design the chef class. Suppose any chef in this restaurant can cook and taste the food. In this restaurant, three chefs are there who can cook different types of food. One is Italian chef, one is Indian chef, and one is Chinese chef. So, we can extend subclass from chef as shown in the code and diagram. Look at the code written here. Every variety of chef is a child of the parent chef class, and each has own cooking and tasting implementation. Now, let's see what is the problem with this code. Suppose there is a food tester who is a type of chef but never does cooking. He does only tasting of the cooked food. Here, the food tester does only testing of cooked food. But we could see the class has overridden both the methods of chef class. If you see carefully, the food tester class have not provided any implementation inside the cook method to make sure the food tester doesn't do cooking. Since the food tester doesn't do cooking but the parent chef class does cooking, this subclass cannot become the substitute for its parent. So here the Liskov substitution principle is broken. To solve this problem, we need to add proper parent to avoid misuse of parent's method. Let's add a class restaurant staff with a method taste, which become parent of both chef and food tester class, as shown in the diagram. Here, we are assuming that any staff of this restaurant is eligible to taste the food. Look at the written code. Both food tester and chef have extended a parent restaurant staff class. With this, both chef and food tester will be able to substitute its parent, and hence we can say the Liskov substitution principle is followed. Let's discuss the next principle, interface segregation principle. As per this principle, a child class should not be forced to implement unnecessary methods from an interface. We have seen in Liskov substitution principle, there we have created a class restaurant staff which is having a method taste, and it has two subclasses, chef and food tester. There, a chef can cook and taste the food, but a food tester can only taste the food. Now suppose cashier and waiter are two subclasses inheriting restaurant staff, as they are naturally type of restaurant staff. A cashier looks after the billings and a waiter looks after the services to be provided to a customer. Since these classes are subclasses of restaurant staff, so by default they are eligible to taste the food. But a cashier should not be eligible to taste the food. It should only look after the billings. Similar case with a waiter. It should only look after serving the food. Look at the code. Since these two classes are subclass of restaurant staff, so they are bound to implement the taste method, but they have left it blank to ignore the implementation. This is where interface segregation principle is broken. Here, these two subclasses are forced to implement unrelated method. Look at the diagram and the blinking code, how we have solved this problem. We have created four different interfaces based upon the behavior, and subclasses are inherited according to their behavior. Here, since a chef can do both cooking and testing, so it inherited both cooking stuff and testing stuff. The food tester can only test the food, so it becomes the child of the testing staff. Similarly, cashier become the child of management staff and waiter become the child of server staff. Each child class has implemented and inherited corresponding methods. Let's understand the last principle, Dependency Inversion Principle. As per this principle, a class should depend on abstraction, interfaces, abstract classes, not on concrete implementations. This makes the code flexible and easy to extend. Let's revisit the example that we have discussed in open and close principle. Here, the UPI payment concrete class is tightly bound with the class payment processor. So what are the problems? As we have already discussed, this class and method will be modified every time if a new payment method is added. For example, credit card. One more if condition will be added to support the new payment method, or in case of removal of an existing payment method. Since this method is open for modification, so the written code is violating the open-close principle. Also, it is violating the dependency inversion principle as payment processor class is tightly bound with the UPI payment concrete class. To solve it, see in the right side code block that is blinking. We have removed the dependency on the concrete class UPI payment and also if-else conditions, and added dependency on abstraction, that is payment interface. Hope you are clear with the dependency inversion principle, and with this principle, it is the end of solid principle. At the end, let me ask you a question related to solid principle. You need to find out which principle of solid is broken here in this given code block. Here, there is a class report service which does report generation, printing the report and save the report in a file. Please put your answer in the comment section and I will put a heart to your comment so that you can know your answer is correct. Before ending, if my way of teaching is helping you, please do like and subscribe to my channel. Thank you and keep upgrading yourself.